morning, everyone. Thank you for being here so early. So my name is Hajer Bouafif. I work as an OpenSearch solutions architect with AWS. And today I will share with you a new approach, how you can build search personalization using agentic memory with OpenSearch. Let's start with a typical search use case, where we have three personas. There are three of us there typing black shoes. However, each persona may think of black shoes of different ways. So the first persona may be thinking of high heels, the second persona sneakers, the third one boots for work. So here the question is no longer about how do we better rank black shoes, is rather how do we know who is running the query and also why they are running the query at that search time. To build search personalization, we need context. That can be different types. User context, meaning their preferences, their history of purchase. Also domain context. This means like industry-specific domain. If you're talking about healthcare, about car parts, marketplaces in general. And business context. Business context means what are our priorities right now in terms of business perspective? Do we have any marketing campaign that we would like to push in our search results? And we need to incorporate those into our search results. Today's focus is on the user context. So how to build search personalization using user context. So traditionally, search personalization can be done in different ways, right? Like collaborative filtering with product recommendations. You can train your own machine learning models with learn to rank, for example, build your feature engineerings, or even have encoding like user preferences in a vector space, basically, and use that vector at search time to build search personalization. However, if we take this example, so let's say we have the user that purchased orange backpack, and they returned this item. In their feedback, they are saying, this is too flashy for my work environment. I prefer neutral tones. With the traditional approaches, usually we'll just have a decay of orange color, for example. But we miss many things. We miss the reason. Like, if this person does not like orange color, they would not be purchasing that product in the first place. Here they are saying, I don't like flashy for work environment, so they regret buying that element afterwards. Also, the alternatives. What are the alternatives to orange color for work environment? Neutral tones. What are these neutral tones? And most likely, the query will stay generic for the three persona that we mentioned earlier. Not to mention that the user context is evolutive in time. The customer, the user evolve in their life. They may be student, then they could become working person, or they have been, I don't know, they've been single, and then they started to look for babies elements. So the context evolve. And in order to build or incorporate this evolution in the traditional approaches that we covered here, that required retraining your machine learning models, that required capturing the drift in the ML models and the vector space that you created for user preference. And we still don't capture the full context, as we mentioned. We're only building that numeric feature, but we miss the whole context of the user and the evolution in real life. So here we need to capture the evolving state of the user, and also an easy way how we can adapt quickly to any changes in the user preferences. This is why I'm recommending agentic query personalization. This means we will use agents and memory. How we'll do that? So agents, they are dynamic in nature. So you can give them many tools, they can give them, like, establish the harness, customize the harness for them. So they can adapt easily to wherever you give them, and they can quickly capture any differences or changes and adapt to that. However, we all know that agents need grounding, right? So the grounding can be in different ways. You can give them the product catalog, for example, for e-commerce. You can give them your PDF documents, you name it. But they also need memory. And here the memory is playing a critical role to capture the user context, evolve over time, and the agents, the memory is their let's say, source of intelligence. So you give them the grounding with the index, but the memory gives them that additional information about what they should consider when they run the search personalization, for example, and rewrite the query afterwards. So the memory captures the evolution of the user context and integrates easily and quickly with the agentic workloads. Here I'm recommending to use OpenSearch for the memory approach. So OpenSearch comes with 4 types of memory out of the box: long-term memory, session memory, history memory, and working memory. I'm not going into a lot of all the details about them. I will show you how to use at least some of them for our use cases or search personalization. And then OpenSearch provides the APIs to add new memories, update the memory, and delete the memory over time. And the agent can easily connect with these memories and write to it. So agentic memory in OpenSearch, it is a feature that has been released in 3.3, and we have new features coming in new releases. And again, OpenSearch already published native agentic memory APIs that the agent can leverage to interact with the memory. You can also store the data in the memory in text format or dense format for vector search and retrieve the context in a semantic way. And then we also have released the context management in 3.5, OpenSearch 3.5, to help the agent retrieve the most important memory information from the long history that you have built in your long-term memory, for example, like building sliding windows or do summaries and so on and so forth. And then you have built-in security features, right? With multi-tenancy personalization, security and access patterns. These are part of what makes OpenSearch as a strong candidate for agentic memory. You can build your multi-tenancy and make sure that your agent only have access to the relevant information for them. So practically, how you will store the data in agentic memory, you have 3 approaches: user preferences, semantic, and summary. So user preferences, this is what I am using right now in my demo I showed earlier, where the LLM will reason over a long history of data that you bring them from UBI data, from their previous purchase behavior, and the LLM will reason and extract the user preferences from all these informations altogether. Semantic approach, meaning, let's say the user have mentioned different things that are related to the same information, but many times. So for example, they have mentioned, I work in consulting, and then they mentioned another time client-facing. So what will be stored exactly, the out here, will be professional context, consulting, client-facing. So it will group that information into one single line, and that will be stored in the memory instead of a lot of redundant information. And then you have the summary approach or strategy. Here we will compress basically the information that we get from many memories into one single line of information. For example, if you have 20 message session, what will be stored here is just hey, this user prefers boutique hotels, vegetarian, and this is their budget by night. If we take the user preference approach, how it works in real life, so you have the first step, user types backpack. Then the agent will load the memory user preferences informations and automatically enrich the user query with these preferences. Let's say backpack becomes backpack leather neutral professional, and then it will also detect the aversions, like this person does not like the flashy orange colors for work environment, for example. And then you can run your search like using neural search with OpenSearch, add the ranks, etc. to retrieve the personalized results. Technically, I recommend to have 2 pipelines, offline and online. What do I mean by that? So the offline ingestion is where you build the user preferences in your memory. So let's say we have UBI data. Who is not familiar with UBI first? Anyone? So, few of you. Okay, so UBI is a user behavior insights plugin in OpenSearch that is built to capture user interaction with search systems. So whenever they type a search query, it will capture how they behaved with all the search results in order, the hover action, the click action, purchase, etc., and so on and so forth. And this is built in to improve the search relevancy, so it is dedicated for search systems. Here, let's say we have already UBI clickstream data that we are writing to OpenSearch. What I recommend is filter out the most important interaction for user preferences specifically. We don't need hover actions here. What creates my user preferences is what they currently purchase, what they actually buy, or what they actually provide feedback, or what they add to their favorites. So filter out what are the most important facts that define a user profile and the preferences, aggregate them if you want by user, and then you will send them to OpenSearch memory. OpenSearch memory here, it will automatically infer, so you have infer true, it will leverage a large language model to infer user preferences from all this historical information that can come from UBI, but also like from, I don't know, their Redshift, their previous purchase orders, anything that are related to the user context. And then the LLM in OpenSearch will automatically infer the user preferences and store them in the long memory as facts. So if we take an example, we have row signals. So they purchased this element, they returned another element. We had a direct feedback saying perfect quality leather, classic style. This is what will be stored in OpenSearch. This is the extracted preferences that will be exactly stored for this user. So prefers neutral, dislike flashy for work environment, value quality leather, and so on and so forth. So here, as you noticed, no feature engineering, no machine learning, complex process pipelines, or ML models training or anything. We are using the LLM reasoning capability to extract these preferences and adapt over time whenever they see a purchase behavior that has been evolved or has been different from what the user has been doing over time. So it captures easily any changes there and outputs the results, again, semantically here. So we are not storing the facts as they are. We are actually regenerating semantic information there. Now, for the online search pipeline. So let's say we have a user that comes in and types backpack. So the agent, first thing, they will fetch the memory. So we will fetch two memories, the long-term and the session memory. The long-term where we are storing the user preferences, and the session memory is where we store the conversation, so to be able to ask follow-up questions. If the customer comes in and types in blue, we know that in blue means the backpack in blue. So we have two memories that we are reading from at this point, the long-term and the session memory. The agent will automatically enrich the query with the attributes that we have captured from the user preferences. You can run the neural search query here. So I'm saying neural search, you can have hybrid search, lexical search, you name it for you. And in terms of filtering for the query rewriting, this highly depends on your preferences. I highly recommend to leverage soft filters instead of strong filters, unless you know that that filter is super important for the user. And then you can augment that with the re-rank step, where you can feed that context again to the re-rank model to catch up on any preferences that you see for the user. And then you have the personalized result afterward. And I do have some asynchronous actions that are doing here by my agents. So all of this is online, is synchronous way. And we have some agents that are running asynchronously. So we have an explanation agent, or call it judge agent if you want, that will detect any mismatch between the original query and the results that have been provided to the user and the preferences. So it will understand quickly if we have captured all the preferences. If not, it will communicate that to the user. So it will come in on the application and saying, hey, we apologize, we don't have this exact product for the user, hence we are recommending these other products that you should look like. So I'm using that as a way to communicate to my user saying, hey, even if you don't find what you're looking for, we are here to help you, and we are providing the most relevant result that we find from our current inventory. I also have the agent writing to different other memories, the working memory. So here we capture what the LLM has, the query that have been enriched, basically, how they enriched the query, the reasoning. And I stored the session memory for the multi-turn context and the history. The history memory is, think about it as an audit trail, basically. We capture all the action, the reasoning that have been done by the LLM and what happened in that specific session to go back to that later and do any analysis of the traces. So quickly before the demo, these are my recommendations for production workloads for agentic memory and for search personalization. First of all, build asynchronous memory writes. So don't block the search path because that will increase the search latency. Make sure that you only write or you only keep the synchronous workloads or steps for the online search. Otherwise, move everything else to the asynchronous path. Then infer user preferences offline, as I mentioned earlier, with the infer in true, not at query time. Cache user profiles. If the user comes in the application and the LLM already retrieved their preferences, you don't need to retrieve that preferences every time the user types another search query. Just cache that and use it over and again. Limit the retrieval of user preferences to the top 5, 10 facts. You don't need to retrieve like the whole history of 10 years or 10 months of data. Only use the LLM, the reasoning capability to only extract the top 5 facts for the user at search time, and that are also related to that specific context, not all the context of the user. Use tiered models. This is very important. You don't always need big, large language model. You don't need to have very strong reasoning capabilities. Use the reasoning capability for the offline ingestion. But online search, use an SLM, small language model. Build the harness around it. Build a deterministic approach if you want with it. But you don't need any deep reasoning because we already know what action they should do. And then set the memory TTL. So here, if you know that the context may change like in like 3 months, 6 months, etc., build that time to live memory to only keep what is most relevant for the user, and always have fallback strategy. I cannot reiterate enough on this one. The fallback strategy can be having lexical search, Canon search, hybrid search, what works best for most of your customers, basically, and have that as a fallback strategy in case the agents takes too long to run, they have behaved in a way that was not expected, so always make sure that you have a safety net in there. All right, so demo time, I promise it will take 1 minute. All right, so the demo is a simple marketplace demo. So here I have 3 personas. I have the anonymous user, where we don't have any personalization. We have the Sarah, that is a young working professional, and Alex, who is a student. So if you start with the anonymous user, and we'll type shoes query. So here we'll have results that are not personalized. You see on the left side here, the query in OpenSearch is only shoes, right? We did not have any personalization. Now, if we move to Sarah, for the same query, this is taking some time because it's a demo mode, so I have some like asynchronous actions meantime. So the query for Sarah, as you can see on the left side, it is shoes, leather, lace up, neutral, black, tan, brown, understated. I also have some filterings here. I have strong filters on the category and the gender because I assume that the category and gender affinity is important for my user, Sarah. And my LLM reasoning is as follows. So I have the original query here, the enriched query, and all the attributes that have been inferred from the user context in the memory. And I'm also feeding all these attributes to the re-rank model again here. And for the semantic aversions, This is, I would say, this is what I'm doing here. Basically, instead of putting the negative aversions, I am translating them into affirmative information because the embedding models are not very good in handling negations. So I'm transforming that to affirmative information for my user and using them at search time. Then Alex user. Is done? Okay. I guess for Alex user, it's the same here. And again, you can, most important part that I wanted to show here is the filtering, right? Like you can also reinforce the filter is the user explicitly mentioned about the filter in the query pipeline here. But anyway, I'm available in OpenSearch booth. So if you have any questions, please come and join us there. Thank you so much.